All right, somebody made a mess with the paper computer. This is terrible. We got to clean this up. So while I'm cleaning it up, I want to talk to you about what is a paper computer, why you would want to buy one, and why learning with a paper computer is better than learning with a real computer when you're just starting out. So let's talk about what is a paper computer. So a paper computer is a very, very simple model of a real computer, the kind of computer that you might have at home on your desktop. Maybe it's sitting on your lap, or maybe it's in your hand. We call it a smartphone, but really it's a computer. There are also computers in your television. I think there's computers in your air conditioner, in your car, all over the place. There's very few places where there isn't a computer chip, very few things. In fact, they call it the Internet of Things, but they should really call it computers everywhere. And in all these devices, they're smart, which means they have like a little processor or a little bit of memory or a little bit of technology, a chip, a logic board that allows them to do stuff for you. All right. So this is a paper computer. It actually fits in this box. And this is the booklet. But if you buy the paper computer online on the epicloot.cards website, if you just get the paper computer, this is all you get. And that's fine. It's not a great way to start out if you're a beginner, because the booklet's really helpful. Kind of explains some basic subjects and then diagrams, and allows you to work through algorithms with the cards, the basic cards. But let's just talk about the paper computer. So a computer is made up of components. Some of them are physical and some of them are logical. In our paper computer, which is very simple, very simplified version, we have memory. And memory in a computer is numbered. We call those numbers indexes. So in our paper computer, I'm doing this out of order, look at that. You get index cards that represent locations in memory. I should probably try to put this in order. So we've got 1, 2, 3, 4, 5, all the way up to 15. We start with 0. We actually start with -1. But we're just going to deal with these 8 indexes, 0 to 7. And so if you have an 8-bit computer, you have memory locations numbered 0 to 7. And I actually always like to include an extra memory location, -1. That way I have some swap space. I can use that to hold some data, because a computer can't just put data anywhere. It has to have a label, like here we have numbers, it has to have an index, and to know where to find the data. So what is data? A lot of people talk about data. So data comes in 2 flavors in our paper computer, and there's many flavors of data. There's character elements and binary elements. So let's talk about binary. Binary elements are pretty simple. They're actually at the root of everything a computer does. It's how a computer counts. It's how a computer thinks in binary. And binary basically is either 0 or 1. So every binary location, let's do an 8-bit binary array, which is called a byte in computer terms. So this is an 8-bit byte. There are also 16-bit byte. As you can see, they're all set to 0. So if I wanted to count to 1, like I saw 1 raindrop, I would just flip this over, right? Actually, by the way, binary is counted this way. So that represents 1. And when I want to get to 2, because the locations can only be 0 or 1, I have to flip this back over to 0, and this is 1, 2. So this is a single 2, and this is your 1's place, your 2's place, your 4's place, your 8 place, 16 place, 32 place, 64 place, and 128 place. And if you buy the paper computer and the booklet and you go through all the algorithms, you'll learn all about this. But this is how computers count. They do it through binary and multiplication, and they represent numbers a little bit differently than you and I do by counting our fingers. So these are the binary elements. Very simple, and they're either 1 or 0, on or off, left or right, true or false, up or down. Okay, so we're going to put our binary cards aside. The other kind of data elements that we have in our paper computer, which is a simplified model, are called character elements, and you'll recognize these because these are letters. Now, letters are a kind of character. You know, numbers and symbols can also be a kind of character. Anything you can type on a keyboard, send through the internet or through the web, these can be encoded as characters. So we've got A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So there are 16 character elements, A through P. And you can't represent it this way. You need an index for each data element. So here we have the A at 0 and the H at 7. Now, if we wanted to, say, swap the F and the E, we can't just pick up this piece of data and hold it in our hand. We have to put it somewhere. So we're going to put it at -1. Then we're going to put F at 4. And we're going to put E at 5. And now we've swapped them. So that's what the swap space, the -1 is for. It's a good place to keep data while we're doing an operation, while we're performing a step in an algorithm. So these are character elements. All right, let's put those away. Now we also have something called variables. And our variables are sort of like bookmarks. In a computer, a variable is used to associate a label with a value or a location in memory. So one of my favorite variables is called temp. It's temporary. Another one of my favorite variables is called result, which could be the output of a calculation. And if you have an intermediate result, you don't know if it's the final result, maybe it's a guess. And we have a lot of other variables here. Length is a good one. So let's just show how a variable might work. Let's say that you have some character elements, right? And you always want to remember the place that is the index that is open, right? So what I can do is I can set the length. I can associate it with index 3. That means I have 3 elements, 1, 2, 3. Remember, counting starting at 0. So the element under index 2 is the 3rd element. And now when I add an element, I can increment my length. I can associate it with the next index, which is 4. So now I know that I have 4. So this might be very useful in an algorithm where you have to keep track of the length of the amount of data that is in memory. So that's kind of basically it. That is your paper computer. You have variables, you have indexes, and you have elements. And again, if you buy the starter kit, you'll get the card basic cards, and you'll get this nifty booklet that kind of goes over a little more details about what I just explained.